right? So we have seen various, first of all, we have introduced the course of soft computing, and then we have gone to the neural network fundamentals, okay, neural network basic models like Pitts model, then we have seen perceptron model, then ADA line, then we have seen the multiple ADA line, then multi-layer perceptron, then we have seen backpropagation network. These are all various supervised models we have seen. Then we have seen unsupervised models, right? Uh, like self-organizing maps. Then we have seen memory-based models, right? So all these various neural network architectures and algorithms we have seen. So basically the purpose of the neural network is to bring the human brain capability of performing calculations. Okay, so what scientists have done was they have understood, they have tried to understand that okay, perhaps the human brain is working with regard to classification in this manner, with regard to clustering in this manner. Perhaps human brain is processing the information, memorizing the information in this manner. And they thought like that and built the models. Can we say, we cannot say that those models are perfect models and able to capture the entire human brain ability of processing things. Okay, still they are evolving. Like we have seen the deep neural networks and all that. Now that is a different part. Now next part of the course is fuzzy logic. Okay. This is another interesting component of soft computing. It provides a way. It provides a way similar to your neural networks. It provides a way to reason about, okay, to reason about things in the practical things of the practical world, practical applications or practical applications. Okay, when I say reason about like the way humans reason. Okay, the way humans reason about it. Okay, I'll just give you one diagram. When I say that humans reason about it, have a look at the this particular diagram and tell me. Imagine there is a scenario like this. To keep a look at the diagram. There is an individual who is standing, and on top of him there is an object which is falling on his head, and there is another individual who is standing there, and this guy is not noticing that particular weight which is falling on his head, but the other person is giving an alert. You see, what is that alert he is giving? He is mentioning that a 1500 kg mass is approaching your head at 45.3 milliseconds speed. Does this happen in the practical applications?
No, sir.
What happens? What happens in the practical applications?
Like he will just tell that some kind of weight is approaching, falling on your head.
Hmm.
Sir, he will say that just move away from the spot. Run,
So,
run, run, like something.
yeah. So this is what happens, right? What happens is, yeah, just look at. The idea is that to alert. Okay. Idea is to give an alert. Look out, or somebody said, run away. That's all. Okay. You need not have to be in a precise state of handling things. A 1500 kg mass is approaching your head at 45.3 milliseconds. Then by the time the guy understands what this fellow is talking, if this is the scenario, it's all gone. The idea is that he has to alert this gentleman saying that look, something is falling. Look out, jump, move. Or else, he may even instead, if suppose he thinks that, by the time he announces and he realizes what is happening and making an action, if it is going to take a lot of time, obviously this gentleman will come and push this boy, push this fellow, right? Some kind of an action. These are all the practical scenarios, right? And similarly, when you look at the other environments, so take an example, you go to your friend's room, and if the friend is moving away outside, and if he says that, hey, wait, I'll come back in few minutes, okay, he will tell you that, imagine if he says that, okay, wait, I'm coming back in few minutes, wait for a few minutes. Do you ask him how many minutes, or you just wait for a few minutes? Hello?
Sir, we wait for a few and we call
Yeah,
him or something.
tell me how many minutes.
10 minutes, sir.
Okay, who is this?
Gagan, sir.
Sorry?
Gagan.
Gagan. Okay.
Yes, sir.
Gagan says, when I say wait for few minutes, he will wait for 10 minutes. Who else? Can someone else tell me how much time you will wait? Our Nadella Venkata. Okay, that's what is Gagan, right? Okay, yeah. Okay, that's what is Gagan. Okay, what about Akhil Raj? What he will do?
So 5 minutes. No.
Wait for 5 minutes. Okay, Akhil waits for 5 minutes. Okay, someone else? Can someone else tell me one more?
15 minutes.
Somebody says 15 minutes. For him, few minutes means 15 minutes. Okay, very good. So now if you look at, now imagine you have to write a program. Imagine you have to write a program. And you are asking the system, you have to ask the system to pause for few minutes. How do you do it? How do you do it? How do you do it? Hello? Here, how do you do it? Will you be able to do it or not, first of all? Can you write a program? If I'm asking you...
Sir, not by conventional way.
Okay. No. See, conventional or unconventional, you tell me, how do you write a program to ask the machine to wait for a few minutes?
Sir, no, sir.
Why? Why no?
Because few is not certain, like it's only qualitative, it's not quantitative.
Okay, very good. Few, somebody said it is not certain. Okay. What is the other one you said? Certain and quantitative, right? We said quantitative.
Yes,
okay. So few is not certain. Few is not quantitative. Few is not a crisp answer. Few is not a number, right? With which you can compute. What computer needs is the number or words? Hello?
Number, sir. Computer needs.
Computer needs a number. System needs a number. You are giving a few as an input. It's not a number. So how do we do it? How do you handle this? Okay. So then I am giving you another scenario. Like look at this particular use case. Okay, where saying that somebody look at like this. Another scenario. Okay. we are saying that, look, you must be taller than this line. What is this line? This is the line. Imagine this is the line. I'm just making it as a yardstick. Okay. What the rule says that you must be taller than this line to be considered as tall. Okay. So this line, when I say this line, probably you think of this particular height of this line and say whatever is that line height, say take an example 160 centimeters or whatever it is, 160 meters or 5 feet, whatever it is, or 6 feet, some measurement you take, draw an yardstick and say that those guys are persons who are above this particular line here are considered as tall. Is that fine to call that? Hello? When I do that, what happens is like this. When I do that, what happens is, imagine I have my x-axis. Talking about height, either in feet or in some centimeters or whatever it is. So this is my x-axis. And my y-axis has the values 0 and 1. Okay. My y-axis has the values 0 and 1. And of course, intermediate values also like 0.5, 0.25, 0.75 kind of a thing. So now what happened? When I say that I am considering as a person who is taller than this particular line. So that means imagine the line is of some height. So that till you reach that particular height, you consider anybody with whatsoever is the height as not tall. But the moment you see a person who is of that particular tall, you say that that person is tall. Okay, rest are all not tall. Okay, is that diagram is are you able to understand the diagram, the graph? Hello? The graph, you say height of an individual is on the x-axis, and if the height of an individual is below a particular number, you are calling that particular person as a not tall. If the height of an individual is above or equal or above a particular number, you are saying that that person is a tall. Okay, not tall, tall. Is that clear? Hello? Hello, are you able to follow that graph?
Yes, sir.
Okay, so when I consider this particular rule that says that, look, you must be taller than this line to be considered as tall, right? So the same thing, it is shown in the kind of a graph where you are keeping the x-axis having various height values of the individuals, and when you keep height of a person whose height is below that particular number, that person is not tall. If the person height is above that particular number, you are considering that person as a tall. Now there are some of things which you need to understand here. There is an element called degree of membership. Okay, sharp-edged membership function. These things we will discuss a little later. For time being, you understand that you are taking the height of an individual. You are taking a height of a person, say 5 feet or some inches, 165 inches, 170 or whatever it is. Then you say that if the height of person is greater than or equal to this particular number, then person is tall. Okay. Now the point is, look at the variables what we have now here. What are the variables you are seeing in this particular case? What I have written here. What are the variables? What are the variables? Tell me the variables what you have seen. Height is one variable, right?
So, and degree of membership is the dependent variable.
No. We will come to the degree of membership little later. Don't worry about degree of membership. Okay. My question is, I have written here something, height of a person, height, tall, kind of these things. Tell me what are the variables here? Height is one variable, right? Hello?
Yes, sir.
So height can assume any numerical value, correct? Now tell me, I'm writing tall. Can tall assume any numerical value?
So we can, if you want to.
You can. If see, it's not if we want to. Okay, don't give this type of answers. Tall is a variable. Generally, we write height is the variable, right?
Yes, sir.
You tell me tall is an adjective or
adjective, sir.
Yeah, can you give a value to the adjective?
Sir, we can fix it as like if
one. Yeah. So So the point is that tall is an adjective. So height we fix the variable. So the point is you are going to use height is the variable because it is a quantitative variable, right? So if you notice here, we are computing based on a variable which is a quantitative variable that can assign the numerical values. Okay. Finally, we are saying that the person is tall. That is the decision we are making it, or that is the classification we are giving it. Okay. So now the point is, if you look at the practical scenarios, again, let us come back to this particular diagram, the first diagram. If I say that if somebody above this particular line is tall and others not tall, what about this gentleman? So this is A, this is B. What about B? B is tall or not?
Somewhat tall.
See, what is somewhat tall? Can you tell me the answer based on the logic what I have narrated here? It is not tall, right?
Not tall, sir.
It is not tall. But in the practical applications, can we say that he is not tall? Is correct?
No, sir.
Similarly, when I say that you wait for a few minutes, imagine Akhil waited for 5 minutes. Okay. But imagine if I am returning back at 5 minutes, 1 second, what will happen? And why if Akhil is saying 5 minutes, and Gagan is telling 10 minutes and somebody else is telling 15 minutes. Can we have such a rationality here or granularity here?
Yes,
so
sir, we can.
When we, hello, yeah, where?
So like the same on the can say that okay, only greater than 160 is tall, something like that.
Correct.
And you're saying 165, so I'm going to say 175.
Correct. So now the point is, when you say that, when you want to bring the granularity, okay, height is 165. When it comes to persons, somebody is saying that 165 centimeters is the tall. Now imagine if you are taking a set of individuals who are from, say, take an example, particular geographical region, such as, from African continent, where typically the height of an individual is much larger than the height of the other individuals. So in such case, even your 5 feet or 5 feet may not be at all, right? So the point is that in a practical applications, in various applications or in a day-to-day life, we deal with or we handle lot of impreciseness. Okay. Uncertainty in information. Okay. So how to handle this? Your fuzzy logic is the means with which we can handle about impreciseness or uncertainty, vagueness in the data. The point is, when you say fuzzy logic, it is different from conventional crisp logic. What is crisp logic? Your Boolean logic. Okay. And when you say that the logic is fuzzy logic, it doesn't mean that logic is not fuzzy. Remember one thing. Okay. Logic is not fuzzy. It is basically a precise logic. It is basically a precise logic of imprecision, approximate reasoning. Okay. Okay. So basically, fuzzy logic is not a fuzzy thing. It deals with imprecision. It deals with approximate reasoning. It deals with uncertainty in the real world applications. Professor Zadeh, okay, is father of fuzzy logic. He introduced fuzzy logic in 1965, and he's a professor of University of California, Berkeley, and he introduced the concept of fuzzy logic. The base root for fuzzy logic is fuzzy set. Okay, it's like your crisp logic or Boolean logic is rooted with classical set theory. Fuzzy logic is rooted to fuzzy set theory. Okay. When we introduce fuzzy logic, what happens? For the same problem of your height that what we have seen in the previous slide. Let us look at this. When you introduce the fuzzy logic, if you see the previous case, we are saying an individual is tall when that individual is above that particular height, and we are saying another individual who is not above that particular height, we are saying that he is not tall. Okay. But what fuzzy logic gives is, fuzzy logic gives a graded values. Okay, look at the graph here on the figure given below. So when you are keeping the height in the x-axis, if you see here, this particular gentleman or the person whose height is at a particular value, we are saying that for him, we are not simply saying that tall, not tall. We are saying that he is belonging to the tall fuzzy set with a particular membership value. Okay. Similarly, look at this particular person. We are saying this particular person is belonging to a particular fuzzy set called tall with a membership value. Okay. We are not saying not tall. Okay. Here in this case, we are saying tall, not tall. We are saying here in the second scenario that say he is if you call this person as A and this person as B, A belongs to fuzzy set tall with a membership degree. Okay, the degree may be 1.0, the degree may be 0.5, degree may be 0.95, depends upon the height of that individual. Now B belongs to the same fuzzy set called tall with a membership degree, say maybe 0.3. Okay. If you look at the previous scenario, this A is belong to the fuzzy set. Sorry, this A belongs to the set. This B does not belongs to the set. So belongs to set. And another scenario you have does not belongs to the set. Okay, this there. So he belongs to the set and he does not belongs to the set. Whereas when you introduce the fuzzy logic, which is rooted to the fuzzy set theory, the fuzzy set theory gives you a flexibility. And the flexibility the fuzzy set theory provides you is that you can map an individual to a fuzzy set with a particular membership degree called 0.95. Similarly, you can map another individual whose height is, say, take an example, a 140 centimeters. He still belongs to the fuzzy set tall, but probably with a lesser membership degree, say 0.3. Are you able to follow? Hello?
Yes, sir.
Are you guys able to follow? Just somebody who could not follow, please raise your hands. Those who could not follow, please raise your hand so that I can repeat. The flexibility that fuzzy set theory is providing than classical set theory. Anybody raised hands? Okay, so I understand that everybody followed it. So again, I repeat, even those who are having some inhibition to raise the hand, your classical set theory gives you only one option, saying that whether an individual belongs to the set or does not belongs to the set. That's all. Whereas the fuzzy set theory provides you a flexibility in the sense that everybody, whoever is having a particular height value, even the height value case, say take an example about say even 50 centimeters. He or she will be still belonging to the fuzzy set called tall. But what differs? A person with height of say 165 centimeters, he will belongs to the fuzzy set called tall at a membership degree of say 0.95 or 1.0. A person with say height of value say 100 centimeters or maybe 90 centimeters, he will belongs to the fuzzy set, same fuzzy set tall, but with a membership degree 0.3. Okay. I hope you guys are able to follow. So now the point is it that my classical logic or Boolean logic, how the Boolean logic is handling the uncertainty? Remember, we have probability theory, right? Somebody may think that, sir, what we are saying is, it is appearing similar to the probability theory. So your Boolean logic uses the probability theory or your classical problems, real world problems where we have uncertainty. We deploy probability theory. Whenever you are using the Boolean logic, still we handle the uncertainty in our systems, in our applications. How do we do that? We do that using the probability theory, right? But now we are saying that we are going to use fuzzy logic in order to handle the uncertainty. What is the difference? Again, I'm saying that, a person is belonging to the tall fuzzy set or a tall set with a membership degree 0.9. Is it like looking like, probability of having something, probability of say 10% probability, 20% probability, 30% probability? So is it that both are same, or what is the difference? There is a significant difference between your fuzzy logic and probability theory. In fact, there is a similarity. The similarity is that both are trying to handle uncertainty. That is the similarity. But the way they handle the uncertainty is the one that differs. Remember, your probability theory deals with or handles or explain, your probability theory deals with occurrence of an event, right? That's what is the responsibility of probability theory, right? Or else chance of occurrence of an event, right? And it also deals with a lot of randomness, right? Whereas your fuzzy logic, it is different in terms of handling things. Fuzzy logic do not deal with occurrence of an event. Fuzzy logic deal with uncertain data. Okay. Look at the case of probability. It's not that you are dealing with uncertain data. Here you are dealing with uncertain data or trying to provide suitable solutions when you have uncertain data. Okay. And another thing is that here you are dealing with linguistic variables. Okay. What are the linguistic variables? You look at the example what we have seen, the tall, very tall. These are all the various linguistic variables, right? So you are defining the sets based on the linguistic variables in the sense that the fuzzy logic is providing you the opportunity to compute with words. Okay, you are able to compute with words. Another thing, previously we have seen in the example, fuzzy B belongs to the fuzzy set with a membership value of 0.3. A belongs to the fuzzy set with a membership value of 0.9. How these values have come? They use, the fuzzy logic uses membership functions. Okay. So what is the responsibility of this membership function? It takes a precise value. What is the precise value? Height of an individual, and map it to fuzzy value. Fuzzy variable, right? The fuzzy variable. So you are taking, say, 165 centimeters or 170 centimeters as a precise value. You are saying that he or she is belonging to the tall fuzzy set with a membership degree of 0.9, with a membership degree of 0.3. So that's what you are doing it. So fuzzy logic uses the membership functions. You don't have membership functions in the probability theory. Right? Are you able to follow?
Yes, sir.
And that's the reason why you call fuzzy logic is handling granularity. Okay. Granularity in the information. So this is about the basic introduction of the fuzzy logic. I suggest you guys to have a look at the book, and tomorrow onwards we will start the fuzzy sets. Okay. And this is one of the interesting topic. At the same time, you know, the fuzzy logic has you know, its own merits and demerits, and there are certain section of people or the scientists who do not accept the fuzzy logic. In fact, they go with only probability theory.